Hello everyone, I am Rahan Masharib and welcome back to the new video tutorial of this Android developer interview series. In this video, we are going to talk about the Kotlin Coroutines. From the beginning of this playlist, I am selecting one topic for one video and explain that topic very well for the preparing ourselves for the interview, and also take a look what were the most asked questions during the interview of of that topic, and then we also take a look at how we should answer it, which point we should cover or not. So we were going to do the same thing for the Android for the Kotlin coroutine as well. So without wasting such a time, let's directly get back to the topic and start from the beginning. Usually for understanding the coroutines, we will see that what the problem comes when our application, the legacy of the application development, why we need a thread, why we need a coroutines, how thread and coroutines are related to each other, on how what are the most asked questions during the interview from the Kotlin coroutines and how we should answer them. So just let's start this. So let's understand firstly that how application flow means if you write the multiple functions there, the how they should work. They should work in a sequence. They will work in a sequence like when the work one get started, it will finish the first. Then work two will be started and finished. Then work three and then the work four. So let's understand one scenario. Work one has started doing work and get complete. Now it's time to perform the task of work two. Let's assume that we have some API calls here. We are calling API, but let's assume that API is not responding at that moment. So what will happen? Nothing app will have nothing to do at that time because we are just waiting for the response to get come, and and as it is not yet completed, so work three have to wait. Here our CPU is also free, but still have to wait. Let's understand what the problem comes in this approach. So let's assume we are not talking about the thread at that time. We are just having a simple program, simple step that how the application runs. We will take a look about the thread and the coroutine as well later, but later part of the video. So like we have a main thread, and main thread have a responsibility to redraw the UI in each 16 second, in 16 milliseconds, so that you will get always a refresh one. So let us assume we are doing work one. We are doing all the work on the main thread. Like one work one when we do the work one is started and finished. When then it started doing the work two. At that time, you see that work two is taking a longer time to get it complete his work. And that time, like like assume that we work two has taken the 32 millisecond to get it completely done. But at that time, if we take 32 millisecond, then what happened? The redraw of the UI will get freeze, and that time if you miss the lock one, two, and three time the frame, then it will show you A and R, but application not responding dialog. That means application is freeze and not responding for the user. So this is the like this will make your application to get completely closed at that time. So this is the problem here when we do some long running task on a main thread. Here the thread is, and the, for to solve this problem, there is a come with a thread, the legacy, which is our legacy in development. So basically, thread help us to run the long running task into the background without disturbing the main UI thread. So this is the work of the thread is. Let's understand it more clearly here that how we can come to solve the problem with a thread. So what we do the rest of the work onto the main thread, which will get complete very shortly, will not take much time. And all those tasks which is need to be get completed and might will take a longer period of time to get complete. We are doing it on a thread. So like here we have a let's assume that we have a one API call. We are working on a, we start that work on another thread. What will happen if we have a multiple task that we have to perform into the background, or that is a long running task? In this situation, we need a multiple thread like thread one, thread two, thread four. So here is the problem with the thread. Like one thread can use a one work only and one work, and for the multiple work we need to create the multiple thread. Creating a new thread is a very expensive operation. So like if you have running on a mobile phone, and if you're creating a lot of thread need a resources from your hardwares. Like if you in general term you can say that if you have a two core CPU, then only those two thread you can create that. If you have a four core, you can create the four one. If you have an eight core, you can create the eight one. So it depends on the resources on the hardware that you have. In this term, creating a multiple thread in a very expensive, and one thread can use to be one position, one operation only. So if you are doing a one operation, you cannot cancel it, you cannot like reuse for another work. So this is the problem here, because when we have to do the multiple thread, why it's how it's difficult to get it managed multiple thread into the one application. You cannot create the lot of them. Here the reason why the coroutines come into the existence, but we will understand for the coroutine what is in, then we will talk about how it come into existence. Let's understand what is coroutine now. So till reaching here, we have talked about two things. First is what is how the application runs in a flow, like when which task will complete the first and which will the later part of the time. And then we also take a look about the threads. So why we need a thread and what it done for us. So here is the coroutine. So basically, as you can say, I have marked it also like I have marked with a different color and the routines in a different color. So basically, it is a mixture of two different terms like go for cooperation and routines for here is a you can assume that a function. So the function that cooperate between each other is known as a coroutines. But when interviewer asks you that what is the coroutine, you don't have to say like it's a mixture of a two words where the co is the cooperation and routine is the function. Let you have to explain him that like you know something about it. So just start with like that coroutines are the lightweight thread. Here, when you say the lightweight thread, you can also say the coroutine is same as a thread, but coroutine we use the coroutine for the same work that we use for the thread, but it's a lightweighted means do not need to create a lot of thread for generating the new coroutines. We can use thousands of coroutine inside the one thread. So this is the means of lightweighted here, and it also help to execute the task which is need to be done first and which is need to be done is a later part of the time. So let me revise it again so it will be better understanding. If you're interviewing, if someone asks you that what is the coroutines, you can say that coroutines is the lightweight thread. By saying the lightweight means the creation of the new coroutine do not need to be creating the new threads, and one thread can like 1,000 of coroutine can be performed inside of one thread. So this is the means how it will how it will be lightweighted. If you still not remember this, just say that coroutine is a feature that helps us to manage the long running tasks that without blocking the main thread. This is the simplest one. It's also true, but better to go in a detail like that. Coroutine is a lightweight thread. By saying the lightweight, it means that creating a new coroutine doesn't need to be create the new thread. So it will be give a more sense to the interviewer like that you have experience of interviewing, you have a knowledge of this concept. Let's understand that how it different from the thread. So just I mean we have this is the coroutine ones and this is the coroutine two. Both are the coroutines are inside of one thread. So we do not need to run the two coroutines into two threads. One thread can use to be handle thousands of coroutines. So what it's happened? We have started some coroutine one and see that we have API call. We have called the API and now we are waiting for response to get back. So means we cannot go ahead because we are still need to be get the response back, and then we can have to fetch the API second. You can also assume that we are like authentication. We are giving ID and password, hit the server to get the response. We check the user are validated and not, and then only we can go to the fetch the user details, something like that. So like that, if, when the first coroutine is both are inside the thread one, any of the thread you can name is according to your wish. So if the here when we started the coroutines and see that we have API calls, we call the API and now we are waiting for the result. So what it do? What the coroutines do? Coroutine will check that is there any other coroutine is pending on a thread on the same thread that we have to do that rather than wait for this. We say yeah we have one coroutine that have a DB call. So we have then the execution with the code will become here. Go and see that yeah we have a DB call. We have done the database call and then see yes without we don't need to wait because we have one more coroutines here which have the response which response has to come. So now the execution will be here and then it will here. And then again we call the API and then check yes we still have a coroutine 2 that have to that data has returned now, and we can go ahead with that. So now we can go ahead and finish the coroutine 2 task then back to the one. So if it is something about thread, then what will happen? Let us assume that this is the thread and this is the thread also. There are two threads. So if API call, if don't have to wait, he did not check that this thread will not check. We cannot pause that. You will not check anything and see you to perform one task into the one thread. We cannot do the multiple task into the one thread. So this is the benefit. Like for the execution, if the coroutine, if there are multiple coroutine into the thread one and checking that if that API call without, we do not need to wait here. The execution, whenever the delay function or suspension function comes into the place inside coroutine, it will check that is there any other coroutines will be there. If yes, then it will be execute that coroutine. So basically the means of that, in very simple words, the means is that if there is something comes in the coroutine where they have to wait or delay, it will automatically go to the send a control to the next coroutine that can be started. So one coroutine can be handled, the one thread can be handled the thousand of the coroutine. So here is the example how should we start the coroutine. Actually, for starting the coroutine, we have a multiple things like we have a run blocking, we have a launch, we have a global scope, and a whole lot of things. We will keep take a look at each of the thing later part of the video. But the better understanding, this is the function that help us to start the coroutines. Here is the launch function. Launch is a coroutine builder that also helps to start the coroutine, which will not wait for the result to get come and like it work independently. You can say that. Here is the delay function. Delay function help us to pause the coding, you can say for 2 seconds, as you is mentioned here. So the name, if you run this in a normal way without delay function, the run blocking will got called, then the first print statement will be get executed. So here the output should be SAM first. But what we do, it will firstly, because here the delay, it will wait for 2 seconds, and rather than the stuck it here, it will run the another part of the code first. So here my name is same with the output. Now the coroutine and what are the difference in the coroutine thread? This is the most important question for the interview perspective. So be remember that. Here is a lot of options you can see that, and there's all other difference, but I'm going to the cover the most important one and the simple to understand that as well. First is the thread is depend on the hardware or the system resource, you can say that. But that means if we are creating another thread, then it will depend on to the system availability, resource availability that you have. But the coroutine are lightweighted thread. Coroutine also, you can say coroutine is also a thread, but it is a lightweighted. Lightweighted means that the creation of the new coroutines will not need to create a new thread. It can be created on it could like coroutines 100,000 of the coroutine can be created within the one thread. So this is the first difference, you can say that. Second, that cancelling the thread is a kind of impossible thing, or it generates the resource leak problem. But the cancelling the coroutine is very easy because we have a suspend function inside that. Second and third is that like the third one is that might not be very helpful for you, or you should not, if you not even mention this in an interview, that will not a problem. But first two you have to mention this during the answer this. The third one is that thread will run in a parallel sequence, but the coroutines will not run into the true parallel. So this is a difference also. So for the difference, you know that creating a thread need a system resources, while creating coroutine do not need a lot of system resources. Multiple creation of multiple thread will be a very expensive operation, but because we need a system resources for that. But creating a multiple coroutines is not as expensive as thread, even not even near the expense of the thread, because a single thread can used to be create like thousands of the coroutines. So that is the lightweight. And the third one is that thread is a parallel run. Thread will run in a parallel, but the coroutine will not run in a true parallel. So this is the difference also. Here is the same slide. This slide is also explains the same thing, but in the very light format. What I have told you in the last slide. So this is the same. Now is the time to come and get to know most about what the interview question asks from the coroutines and how should you answer them. The first thing is that what is coroutine. So let's get to the on that. So here it's like I already explained what the like official documentation says about the coroutine is a lightweight thread, but saying the lightweight means it's creating a does not allocate a no thread. Instead, they can pretend like they have predefined. We will explain that later. But you know that in the simple words, you can say that threads are the way, coroutines are the lightweight thread. When saying the lightweight means for creation of the new coroutines will not require to create the new thread. So you can say that in a simple words. So this is the official documentation. But if you want to impress the interviewer, you have to go with like the coroutines meet with the two different words, co and routines. Co here is the cooperation and routine here is the function. So you with a simple word you can say that coroutines are the function that cooperate between each other. So this you can say that, and then you can say that it's a same like a thread, but the difference is that it's very lightweighted rather than thread. And why it's lightweighted, I already explained that because we do not need to create a lot of thread. We can thousands of protein can be handled within the coroutines as well, and it can do the same things for you what thread do for you. So this is the reason why it's the same as a thread and how it's a lightweighted and what the benefit, how it's beneficial for us. It will cover all those 3 points. Now the next question is come arise here, like coroutine dispatchers, their type and work. So whenever someone asks you the coroutine dispatchers, understand that like as we are keep talking that coroutines are coroutines like one thread can use the multiple coroutines, but when we start the how we can like pass the information that which thread we want to run on this coroutine. So basically, all the application have a thread pool. Thread pool means where the set of threads are available to use. And generally, there are thread for IO operation, default operation, and the like one more. Sorry, I forgot at a time. Sorry for that. So basically, we have a set thread pool which contain the thread, and we need to use the thread to do our work. So how we decide, how we tell the coroutine that which thread we need to be executed on that. So for that we have a coroutine dispatcher. So means the coroutine dispatcher help us to choose the thread. So the coroutine will execute on which thread. This is the definition of the coroutine dispatchers. So basically, the coroutine it have a three time basic type. Basically, the default one, the main one, and the IO one. The main one is like if we want to perform some coroutines on a main thread, and the IO for the IO operation like a networking call, and the undefined basically if we do not have any define the a specific part of the dispatcher if I were on the thread, then the coroutine on which we start the coroutine on the nearest possible thread it will be used for execute its coroutines. Basically, the IO we use for the IO operation like networking call, mains for use the UI related things, and the undefined we'll use for CPU intensive work. So this is the use of that. So for better understanding, let me repeat it again. Coroutine dispatcher help us to choose on which thread we want to execute our coroutines. So basically, you can say that in a simple word, coroutine dispatcher help us to choose the thread for execution of our coroutines. So this is a simple and sweet answer and exactly the point answer for the interview. And there are the three types: the IO, the main like dispatcher man, dispatcher IO, and the undefined. Main you can always understand that as you have the main thread, the main dispatcher do the same thing. It will execute your coroutine onto the UI thread or the main thread. IO dispatcher will help you to execute your coroutine into the IO in a thread where you need to call the IO thread. You can say that where the networking and this networking operation everything. And undefined basically execute your coroutine into the most nearest thread. You can say that in term of the most nearest thread means if you are doing some work on writing the application, writing your code on that on when on which thread you start your coroutine, it will run on that thread. Like if you're starting in main thread, it will run on the main. If you turn in the IO, it will run on the IO. So it depends on the nearest possible thread that it can be coroutine can be executed, and it execute your coroutine into the same thread. Now, question is coroutine scope and their types. So, coroutine scope. Whenever you are listen the word of a scope, scope means the possibility that coroutines can be live. Coroutines can be live. By saying that, it means like everything in application is a life cycle. Like the activity is a life cycle means the how long activity will be live. It is the activity scope, and we have a life cycle of the activity where whenever it destroyed, it will got the destroyed. So basically, the means of coroutine scope is that how long should a coroutine will run, like how should our activity run. It's the same like that how should coroutine means if you're doing some coroutine work, if you start as a coroutine, So how should it long to work? It work till your application live, till your activity alive, or till your model alive. So basically, there are the three scopes available for the coroutines. First, the global scope. Second is the life cycle scope, and third one is the view model scope. So by saying this global scope, you can easily understand with the word of global. It will be not depend on you any of the activity. It will depend on the application. As long as your application alive, putting your work, your protein will be alive at that time. When you manually end it, then only, yeah, whenever your application get killed or you end it manually, then only this protein will be get destroyed. Life cycle scope will be like depend on your activity. So until your activity is live, your protein will be alive. And the view model scope is for the view models. Like if until your till the view model is alive, till then your protein will alive. So means if you started protein into the global scope, it will be long lasting until your application is running or alive. And this is the most highly possible or highly long, you can say that the protein is available for us. This is the all. If you want to like your protein will be live longer, live long last, so you can use a global scope. Life cycle will be activity based. You can simply say that, and V model will be V model based. Until V model and the activity will be alive, they both will be alive according to the respective scope. So for that, if you don't understand, remember that just say global scope will be available throughout the application. Life cycle will be available throughout the activity, and the view model will be available. View model scope will be available throughout your view model. So you can say that. So coroutine builders, this is the again the next question is coroutine builders, their type and the work. So basically coroutine builders means the coroutine starter. Which one start the coroutine? So there are the three types. Coroutine builder function, you can say that as a definition that coroutine builders are the function or construct used to initialize and launch the coroutine. So basically coroutine builder means the coroutine starter. So there are the three options we available first: launch, async, run blocking. Launch, you know that is something like fire and forget. You can start a coroutine, forget about it. We do not need to get the result back. Testing help similar like a launch, but it return you something for you. Return some like uh, return something for you that will be a future value, or you can say that. But when you interviewer ask you, just say the launch is a fire and forget, means you start the quarantine and not waiting for the getting the result back. But async is used to get result back. Sorry for that. And the run blocking will you can say it blocks the current thread under the protein complete. So if we want to block our thread, run blocking using, so it will block the thread until unless our protein completely done its work. So this is the difference. For the launch will fire and forget, async will like fire and waiting for the result, and run blocking will block the thread until the all the protein work will get complete. The next question is the difference between the launch and async. So launch we understand completely like it's a fire and forget. So we do not need to get the result back, then we use the launch. But the async is like it wait until wherever you write the from the where point you write the await function, it will wait to get the result back of that, and then only it will go ahead. So these are the difference. We already explained this in our last slide, but here is the one more question is the commonly asked. So I make one more slide for it and answer it. Run blocking function, run blocking we always see the difference is that like run blocking, it will block your current thread until the full coroutine work get completed. Basically we use it in a testing purposes. Here is the one more important question, and very important question, the cancel the coroutine and why it's important. Like we are talking about the correct coroutines. This is one more benefit of, you can say that while I explaining the benefits of coroutines, I explained that thread cannot be cancelled, but coroutine can be cancelled manually. So this is the most important benefit as well. And here the question is that why, if it's a benefit, why it's important for us. The importance for us is that basically whenever I come into something like cancel thing, so you like the first benefit you can add from your side, even you don't know about it. So just say the finishing the resource, yeah, releasing the resources is that make that in benefit, because we are when like nowadays application are more intensive. We need to be more conscious for the resources, that how many resources we use and how early we can release it. So cancelling the coroutines will help us to help us to free the resource. We will take a look more benefit of canceling the resource into the next slide, but understand for how we cancel it. Here you can see as an example, we are starting a coroutine with a run blocking. We have launched something which will contain into the job and just perform the cancel action inside it. It will get cancelled. Here like a two way, like this is the for the job reference, and when using the timeout. With timeout is a function. Just call it, provide the like duration, and it will get cancelled after that. So this is the two way like jobs and the run with timeout we can use for cancel the coroutines. So whenever the interviewer asks how we cancel the coroutine, just say we have a two types that we can help us to cancel the coroutine. First is a like job reference, and second is a timeout method. Now it's time to understand and take a look at how it's important. The release resource management, you can say that like releasing a resource is one of the point that help us that coroutine cancellation of the coroutine help us. Second is avoid unnecessary work and avoid memory leaks. Simply memory leaks means if you like release the resources, it will avoid the memory leak as well. And avoiding unnecessary work when we release the resource, when we do not have to do anything with that. So this is the avoiding the unnecessary work. Here is the one more important question, and it is a question where the interviewer asks you and the developer get confused with context in a quoting and how it differs from the launch. So basically, like understand a situation where we are starting a coroutine into the IO thread, and we need to back it into the thread which is like another thread. So basically, what we are doing it here, we are starting a coroutine into the one thread and getting it result back and doing rest of the part under the another thread. So this is we are doing the context. We are changing the context of the coroutine. So whenever the situation comes where we have to change the context of the coroutine execution, then we will use with context. Here you can say that this is the like launch method. We are launching something and doing on the same thread. We're not changing the thread here. But here you can say with context, we are using it to perform our coroutines into the dispatcher IO on an IO thread, and then we are using the run blocking. Run blocking will get called only in a main thread. So this or we are fetching the result here from here. So what we are doing to change the like context of the coroutine. So whenever the time come or situation come, like we have to switch the context of the execution of the coroutine, then we will use with context. Here is the global scope in coroutines and when it should be used. When it should be used. So global scope we can already take a look while I was explaining about the scopes. So global scope is the scope which is depend on the application, not on the activity. So until your application is last, your proteins will be last. So this is the maximum lifetime and lifetime of protein available for us right now, because it will be long last until your application long last. So this is the use of like this is where you can describe the global scope, and the use it should be if you're doing something that should be like long lasting, you need to be long lasting throughout the application life, then it is very useful for you. Here you can see that benefit of using Kotlin coroutines over the thread. We already see that while I was explaining about the benefit. But this come into the interview question as well, so I write it here again. So simple and sweet, you can say that thread is a very expensive, because for doing the multiple tasks we need to create the multiple threads, and creating a thread is a very expensive operation. So but in a coroutines, and one more thing you have to add on a thread, that thread one task can only be performed into the one thread. So that will make the thread very expensive for us, because one task can only be performed into one thread means we must have to create the another thread for the another work. In this sense, if we have a hundred of work to do in the background, we have to create the hundred of the threads, and creating a thread is very expensive because we need a resources for that. We need the resources, and not each other device always free food like that. Because I told you like that if you are something related with the hard working, then you know the thread basically depend on the core of CPU. Like if your machine have a two core CPU, then you can mostly create the two thread. If you have core of thread in CPU, then you can create the four one. If you have eight, then eight one. So this is the way. It's very expensive to create the new thread. But creating a new coroutines or multiple coroutines is easy, because it do not need that level of resources. and one thread can use a thousand of coroutines. So even if we need to do a multiple task inside the coroutines, we can do like we can perform all those tasks into the one thread. Or maximum, if you want to take, you can take also two threads because we have a thread pool. But when we explain about the benefit, you said that creating a coroutines is easier than creating a new thread because one thread can help us to create the multiple coroutines. So when you answer that, just say that creating a thread is a very expensive, but the creating a coroutine is not a very expensive. One task can be handled inside the one thread, but and like that. So it's expensive, and but we can use same thread one thread for a multiple coroutines. So it's not as much as expensive. Second, that nowadays we have a thread pool. Thread pool means that we have some thread already created there. We can use that. So we can switch the thread for performing our task in the coroutine. That is, make our task very easier to like easier to perform, and very like it will take very less resources to get it complete. So this is about the thread. Now the cancel a thread is not possible. If you do so, you might be leak the memory leaks or something. But canceling the coroutines is very easy. So to say another thing, that simplicity and the readability is also there in a coroutine. So these are the benefit of it. So thanks for watching the video. That might be possible while watching the video. You have experienced some of the lag into mobile because the lid is suffering with a throat, and some has the winter also. So might be the reason of that. My voice will get shrink during the talking. If so, if you're not able to understand any of the things, or might be some of the question or some of the concept you'll not get clearly catched in this, and do not forget, do not hesitate to reach me out. Just write a comment into the comment section. I will try to reach you out as possible, as early as possible for me. Thank you for watching the video. If you like it, do share, subscribe, and don't forget to share it with a friend. Thank you for watching.